Okay, so let us start.
Okay.
So in the last class, we discussed about electric field, right?
Yeah. Yeah.
Today we will recap what we studied just a little bit, and then we will do some questions based on electric field, correct?
Mm.
So what is electric field? E. It is the force experienced on the charge
Uh,
Q that is
on,
placed at that point, right?
yeah.
Suppose there is this charge Q placed at this
In an
point,
electric.
right?
Yeah.
We want to find the electric field due to this bigger charge, which would be radially outward. That will be learning later how we calculate the direction of electric
Okay.
field. So this would be radially outward. This electric field is being emanated in all the directions spherically, right?
Yeah.
Isn't it? Now there is this charge Q here. We want to find the
Yeah.
electric field at this point O.
Yeah.
So this is the positive charge, right?
Yeah.
So the electric field is just the force experienced on this charge,
On
isn't
discharge.
it?
Yeah.
What is the force experienced?
Uh,
K
Q cube
Q
on R squared.
Q divided by, let's suppose this is R square, and since this is a vector, let's say we draw a small r cap here in this direction. This is r cap, correct?
Okay.
So in that case we wouldn't be needing r cap
Oh,
here.
okay.
Now to find electric field, we just divide this force by this charge where we want to find the electric field, correct? So this would be F is equals to K Q R vector, unit vector, divided by R square divided by Q. So that comes out to be K Q upon R square R cap, correct? Just a second. I need to put the charger in. Okay, so now this would be electric field, not force, because we divided it by Q, right?
Q. Yeah.
So this is the electric. Now what can you conclude from this? This is electric field KQ by R square R cap.
Yeah.
So
So
electric field is being
electric
generated
field.
by this charge, right?
Yeah.
So
So
then
electric
only this
field.
charge will be coming into this point in the numerator.
Yeah.
The charge which is generating the electric field, or the charge due to which we want to find the electric field, would be here, right?
Yeah.
Not the other one, that at where we want to find the electric field. That charge won't be in the electric field, this equation, right?
Yeah. The small Q.
Yeah, small q is not there, right? Isn't it?
Yeah. Yeah.
So let us do some questions on this basic concept. And now I told you the units also, because since this is a vector, the force is a vector, so electric field would also
Oh.
be a vector. The units were Newton per coulomb, right? And the direction, because since it is a vector, we need to define the direction as well. So the direction of electric field is same as that of force, and the force direction in this case
It's
is
R
the
cap.
r cap direction, right? So direction is in the direction of force. This is we can write in the simple way.
Yeah.
Find the direction of force and give that to the electric field. That would be the direction of electric field. Correct?
Yeah.
So let me put in some questions here. Okay, so this is an NCRT question.
Okay.
The question is this. The electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude. We'll discuss about it, what is uniform and what is non-uniform electric.
Okay.
But for now, you think the uniform electric field is which in which the distance between the two electric field lines is the same. Okay, so here the distance between these two and these two and these two all is d. Okay, because the uniformly spaced, right? The
Yeah.
uniformly spaced lines leads to uniform electric field. So for this question you can just understand like
Okay.
this. So there is this uniform electric field. An electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude this. So the electric field magnitude is given to us. Figure 1.39. So let me draw the figure as well. Let me copy the figure in fact, because drawing would take time. So figure is this. Okay,
Yeah.
this is the figure, first one. There are two figures. This is for the first one because there are two parts for the problem. So this is the electric field, this direction, the arrow one. Okay,
Yeah.
the magnitude, that means E modulus, is given as 2 into 10 to the power 4 Newton per coulomb, right? And this electric field is going from positive to negative. So I told you also how to find the direction of electric field at any point. So if we want to find the electric field at this point due to plus charge, this is the positive charge, right? So
Yeah.
positive charge always
Uh,
lead to electric field that is outwards, isn't it?
uh,
If it were a negative, then that would be a different scenario, opposite. So for the positive charge, the direction of electric field is outward. Now if we want to find the direction at this point, correct?
yeah.
So we put in a positive charge here, and I told you that the positive charge will always be in the direction of electric field. The force on the positive charge will be in the direction of electric field. This is a very important statement to remember. So the force on positive charge is in the direction of electric field.
Force on.
Okay,
Yeah.
electric field direction we know already. This is this. So the force
Yeah.
on this charge would also be on in this direction, right?
Yeah.
If it were a negative charge, then the force on this charge would be in this direction, because
Yeah.
you know already that if this is
Opposites.
negative and this is positive, they would attract each other, right?
Yeah. Yeah.
That's why. So that is a simple rule. If they both are positive, then they would repel, then it is natural
Yeah.
for it to be outward. So that's why he drawn like this. This is positive, this is negative, and the electric field is going from positive to negative. Correct?
Yeah.
So the question is something like this. So this is the electric field, and he says uniform electric field. Why? Because they are uniformly spaced.
Yeah.
All right.
Yeah.
Now see what is given to us. So electron was initially at this highest point, let's say, or maybe whatever, maybe in the middle.
Yeah.
It falls a distance of 1.5 centimeters.
Yeah.
Now we need to find the forget about the next statement because it is about the B figure. Okay,
Okay.
we need to find the time of fall in each case. So there are two cases. The first one is this case. Now in this case we want to find the time of fall. Remember, there is no gravitation here. All right, so the
Yeah.
only thing that is existing is the
Charge. I mean, electric field.
electric field. So how will you calculate?
Um.
Now, first of all, let us convert it into meters. How would be? How much?
Uh. Zero. I mean. Cease.
Divided by 100, right?
Yeah. So it would be 0.15.
0.15, correct? It was
Yeah.
2 points before
2
this.
points. Yeah.
So this would be this much. Now, can you think why this would fall down?
Because it's opposite.
No, I mean, I told you that a charge placed in an electric field would experience a force.
Yeah.
That's why it would come
So
down or come or go out upward. We don't
go
know.
up. Yeah.
So how would
But like
you how can you
the
tell
reason
how can you tell
is
whether it would be coming downwards or going upwards? How can
because of the charge.
so
So like in the first one it says an electron.
yeah, all right. So the negative charge would be moving in the direction opposite to the direction of electric field. If it were positive, it would experience a force in the direction of electric field, right? So
Yeah.
he is all absolutely correct that it would fall, right?
Yeah.
So we need to find the time of fall. That's the question.
So it will be similar to
Mhm.
wait. Since it is accelerating,
Correct. Very good. Very good.
right? So
Yeah.
we will use the equation S is equals to U just half h squared.
First of all, we can invoke this equation. Force is the magnitude of force is mass into acceleration.
Acceleration, yeah.
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 And so in order to find t, because if there is a force involved, then the motion of this electron would be governed by the set of equation of motion. So to
Yeah.
find t, we can either use s is equals to ut plus half at square.
Uh,
I think this would be fine because we are also given the distance
distance.
traveled is s in
We
place
need
of.
to find A though.
Oh yeah, we need to find a,
So
and in any case, is u 0? Yeah, we would assume that it is 0.
yeah,
All
yeah,
right.
yeah. Because it is at rest in like the beginning,
So
right?
u is 0, then it would come down to s is equals to half at square. Now if you observe this equation, in order to find t, we need a and s, and s is already known to us in the form of d because that
Yeah.
would be the displacement of the electron from initial to final position.
Yeah.
And we also need this a here. So how would you find this a? By using the
With
force is
F
equal to ma formula, right?
M A, yeah.
So a would be f
Force
upon
upon
m.
mass.
And what would be the force
Force
on this
force will
electron?
be force will be electric field
Yeah, it would be due to the electric field. Very good.
into Q, right?
So it would be due to the electric field. Now, what is the electric field? It is
We know
force
what electric
upon
field is.
charge.
Yeah.
force upon the given charge, which is electron here, isn't it? Because
Yeah.
on the denominator we put the charge on which we want to find the electric field at. See here this is q, which is a small q, isn't it? Not the bigger q. We want
Yeah.
to find the electric field at q, that's why it is plus small q. Here also we want
Yeah.
to find the electric field or the force at e, so that's why I would put e
Q.
here. Now to cross multiply, so f would be e, 1 second, equal sign would be e into electric field, isn't it?
Yeah.
Let's say this is first equation. So from first we can say that a is equals to f, which is e into capital E, which is the electric field, although I should put a minus sign because that is an electron,
Yeah.
upon m. Everything we know. E is the charge on the electron. What is that? 1.6
Charge.
into 10 to the power minus 19 coulombs. Electric field is given to us, which is a
Yeah.
uniform electric field all throughout. See, at any point in this space, at any point, the electric field would be 2 into 10 to the power minus 2 into 10 to the power 4 in magnitude.
Yeah.
That is what is meant by uniform electric field. If it were not uniform, we could not judge the electric
Sure.
field at one point
So it would
due
be
to the
different
other.
everywhere.
Would be different. So what is that? 2 into 10 to the power 4. What is the mass of the electron? It is 9.1 into 10 to the power minus 31 kilograms. So how much is it coming out to be? Can you calculate it
Oh, yeah.
using the calculator?
Oh,
How much is it?
1 minute.
This cancels out already. 92 into the power how much? It would be minus 19 plus 30. It would be 35 minus 19, which is 10, 16. Anyway, so
Huh?
I don't know, it is 32 by 91 into 10 to the power 16. Okay,
Yeah.
now you need to find what? T. So in order to find t, you need to use s is equals to half at square, because u is 0, that's why the first term goes to 0. S
Yeah.
is 0.015 meters. Half into this a you can substitute here, 32 by 91 into 10 to the power 16 into
16.
t square. And after solving this, you should get something which is, let me calculate it, it would be 2.9 into 10 to the power minus 9. Okay,
Yeah.
this is the time. Now for the second part we have this figure. So in the second part,
It's the same question, but it's the
the
proton.
electron is replaced by a proton, which is represented by either p, or I don't know, he represented it by plus e. We need to find the time of fall again. So
Yeah.
in this case, would
We'll
it
go
fall?
upwards. Upwards? Like in the same direction as the electric
See,
field.
the electric field direction has been reversed this time around.
Oh. See that. Okay, yeah.
So then the proton would be accelerated in the direction of electric field, that is
Yeah.
downward.
Yeah.
So the direction is same, that means it would fall obviously. But we need to find how much would be the time of fall in this case. So what do you think? Would it be the same or something different? It depends upon factors, right? For example, what is S? S is the same for both the cases
Yeah.
because the same distance has been traveled, and the magnitude of electric field is also the same, although the direction is different. But we are concerned with the magnitude, that is modulus of E. So that means that in the formula, in this formula, S would not change, right? This we need to find obviously from this formula, right?
Yeah.
And in this formula, you can observe one thing: electric
The
field is the
charge.
same. Charge, the charge is all the same because there is the difference of the positive and negative sign only. The charge on the electron is minus 1.6, although we don't write it in here, you know. So the electron charge is how much? But that's negative, isn't it?
Yeah.
The proton charge is the same but positive.
But without the. Yeah.
But there is a difference in mass. So you can write here mass of electron for the sake of convenience. So mass of electron is how much? 9.1 into 10 to the power minus 31 kilograms, right? But the
Yeah.
mass of proton is not this. It's 1.67 into 10 to the power minus 27 kilograms.
Yeah.
Okay?
Yeah.
And so the answer would differ. You can calculate it, it's the same thing. Or you just to put the
That's
values.
not. Yeah. Yeah.
So this is the time for electron, time of fall, and time of fall for proton would be, if you calculate it, it would come
One
out
point
to
two
be
five into 10 raised to 7.
1.25, right?
Yeah.
10 raised to the power minus 7 or what?
Minus 7. Second.
So you need to remember this, although this won't be coming, although they write it in the at the top, but
Oh,
they
okay.
may not because they have done such things in the past. So you should learn, although you might already know, electron charge,
Uh,
proton charge.
okay, so they won't give this in the exam?
They might give, but I don't know whether they would give.
Okay.
Let's do some more questions on this.
Oh, my stomach is hurting. Can I go?
Uh,
Oh,
no, because we need to do. You already did not do the homework.
okay.
Yeah.
Let's do another question.
So let me tell you one thing before doing another question. Electric field due to point charge. Okay. Electric field due to a point charge. So suppose there is a charge q, this is the origin, there is this charge q placed at this point, and at some point p away from it, we need to find the electric field. So first of all, what we need to find this r, isn't
Yeah.
it? This is the r, and let's say this is the test charge q naught, or whatever you call it, because we call that q already, so
Yeah.
that's why we call it q naught. What do you say about the direction of force on this charge? It would be in the direction of electric field in this way.
Yeah. Yeah.
Force would be directed outwards, right? So what would be the
Yeah.
force? I'm writing this again so that you can remember it. Then
Okay, Q
Q
naught
naught upon R
upon
square.
R square.
Correct. And there is some R vector. So this is our unit vector, the unit vector of this can be some
Okay.
unit vector. This is the force. Now what would be the electric field? Electric field would be
Force upon
k
Q naught.
q by r square. If you want to write direct, you should be able to write it directly.
Okay.
Okay. What is electric field? K
Uh,
q by
Q
r square. Which
R square.
q? The q due to
The
which we want to find the electric field. Okay.
okay.
Due to which, remember this. So we want to find the electric field due to this charge. That's why it came in here. Correct. And again, because this put in a vector sign, so unit vector
Right.
here.
Yeah.
Now you can see one thing. This k is a constant. This r is
Yes.
already constant because we have set up all everything. So this would not change. We don't change the point p. Correct. So if we don't change the point, for example, if we draw a sphere or circle like this, no, not like this. Like we need to draw it. Hmm, this way. This is a circle, although it is a sphere. In real world, it would be a sphere which is at the same distance from point O. Correct?
Yeah.
Oh, what happened? What happened? I just clicked some random icon. Just wait a second. So, coming back to this is the point P here. Now, all the point in this locus, on this locus, would be r distance away, isn't it?
Yeah.
This is our distance away.
Yeah.
This is our distance away. This is our distance away. Now, in this context, we can say that r is constant for this. Okay? For this locus, this r is not going to change, right? And q is already, we have fixed some charge. This is placed here due to which we want to find the electric field, correct?
Yeah.
This is that charge q.
Q.
So, in effect, you can say that the electric field at all point on this locus would be the same in magnitude, correct? Now observe one thing. If we suppose change r and keep everything constant, so then in that case what would happen is electric field would be inversely proportional to 1 by r square.
Okay.
Why? Because everything is constant. Proportionality sign takes into account
Oh yeah.
the things
Okay.
which are variables, isn't it? So
Yeah.
k is already a constant, q this is fixed, this is not gonna change because this is some charge placed at origin due to which we want to find the electric field at. Now if this r is gonna change, so at different point we are gonna get different values of electric field,
Yeah.
and that would be governed by this proportionality. So electric field would be inversely proportional to 1 by r square. That means that as we increase the distance r from the origin, because this is r is initially this r1, then initially r2, and then r3, and so on,
Yeah.
then electric field would decrease by an amount which is inversely proportional to the square of r, right?
Yeah. Yeah.
So that is the conclusion that we need to draw here. That electric field due to a point charge, remember, we are we are concerned about a point charge as of now. Electric field due to a point charge is inversely proportional to the distance, okay,
Yeah.
at which we want to find the electric field at. But you can say if r is fixed, then in the sphere, in the spherical locus, the magnitude of electric field would be
Wait, what are you
same.
calling this? Locus?
Locus.
Oh. Okay.
Okay, this is the locus, the spherical ball, what you can say. So you can draw many balls now. So on this
Yeah.
r1 ball, the electric field would be fixed at any point. On this r2 ball, which is
Yeah.
spherical, the electric field would be fixed, right?
Yeah.
So that's why we say that such a field is called spherically symmetric. Electric field due to point charge is spherically symmetric, isn't it? You know what symmetric is?
Yeah. Like
Symmetry is right. So,
symmetry and then
so the
asymmetry.
symmetry here is spherical. There are many types of symmetry you will be reading in the future lectures. Some symmetry are cylindrical, some are oval, some are whatever elliptical, different types of symmetries. Some are spherical. So here we have a spherical symmetry. So this is the important point that you need to know, that electric field due to the point charge is spherically symmetric, or we also call it by some very famous name which is called as radial. Okay, it is like it came in from the radius concept, right? Radial means like on some radii it would be the same, on some fixed radii, correct? On
Yeah.
another radii it would be some fix. So you call it symmetrical, spherical symmetrical, or radial. Now if you want to find the electric field due to a system of point charge, for example, we have, I'll tell you this in a very short time. Suppose we have a charge q1 here, we have a charge, another charge q2 here, and another charge q3 here. We want to find the electric field at this point where a q charge is placed, correct?
Yeah.
So what we would do is, now this charge would be emanating some electric field of its own, this of its own, and this also of its
Yeah.
own. Let's say this is the r vector for this, r2 we call it, and this is
Or one.
r1, this is r3. One would be pointing in this direction because the force due to this would be in this direction, force due to this would be in this direction, force due to this would be in this direction.
Yeah.
Now this is simple, that electric field due to a system of point charge would be the sum of the electric field due to the individual charges as if one was present at a time. What does that mean? So
It means that the individual charges.
yeah, so if you want to find the electric field due to one, forget everything, you find E1.
And then E2, and then E2.
So E1 would be K Q1 by R1 square. E2, let's
KQ2.
remove the magnitude symbol. Let's suppose we are finding the electric field vector itself. So that would take in R unit vector here, R1. E2 would be KQ2 by R2 square, R2 cap. E3 would be because
K,
for
Q.
each E we are assuming that the other charge would not present.
Yeah.
KQ3 by R3 square
Perfect.
R3 cap.
Yeah.
Now find the electric field due to all of them at this
And
point O. Electric field at point O due to all the charges would be the
yeah.
sum, vector sum of all the charges. Remember, vector sum is not the magnitude sum. Vector sum of all the electric fields due to each charge that is present.
Percent, yeah.
Okay. Simple rule, the parallelogram law of forces, isn't it? Because since suppose this is electric field 3, this is electric field 1, this is electric field 2, what you would do
Yeah.
normally, you would add them vectorially, isn't it?
Yeah.
So that's
Yeah.
what we are doing here. It is very simple concept.
No, it's parallelogram.
Yeah, you would be needing to apply parallelogram law. Let us do some 1 2 question and then we will stop here today.
Oh, phew. Okay. I didn't write any of this. Wait. Can you scroll
You can
up?
write, yeah. From the
No. From the place where you start explaining this new. Yeah.
okay. Okay, so let us do another question. Can you hear me?
Okay. Yeah.
Okay, so let us do this one. This is a good question. You will understand a concept or two about electric
Two.
field.
Two
It's just a way of
concepts.
saying, yeah, you can understand. So 2 point charges of this much
Solid.
coulomb,
Yeah.
they are all positive. So 5 into 10 to the power minus 19 and
And
plus
20
20,
to 10.
10 to the power minus 19 coulombs. They are separated by a distance of 2 meters. So let's draw a 2 meter. Let's say this is 2 meters. Find the point on the line joining them. So this is the line that joins them, at which the electric field is intensity is 0. We need to find a point on this line, okay, where the
Yeah.
electric field intensity means the magnitude of electric field, okay. So we
Yeah.
need to find a point where this electric field is 0. Electric field intensity is 0. Let us suppose this is the point P at which electric field intensity is 0. This is point A, this is point B, correct?
Yeah.
Let's say it is at a distance x from A, then the distance of this point from B would be 2 minus x, correct?
Yeah.
Because this is the whole length is 2.
Those two.
Now can you think why is asking such question? How can the electric field be 0 at some point between A and B? See, let me draw a rough work
Maybe at
here.
like the what do you call that? At
What?
the locus thing?
Not
I
the
don't know.
locus.
I'm not sure.
Uh, I'm asking about the line joining them. This is the line that joins two charges, suppose. This is Q1.
Oh right, electric just okay, yeah.
So this point is P, suppose. And there would be two electric field at this point. One would be due to this Q1. One would be due to this Q2. Right? Now what would be the direction of electric field E1 due to Q1? This direction?
Yeah.
Yeah, because
And
electric field direction is assumed as
yeah.
we put in a positive charge here and then calculate the direction of force,
Yeah.
isn't it? Because they are positive. So positive charge would emanate outwards. That's why this electric field. So this is E1, let's say. Correct?
Yeah.
and due to this charge q2 there would be another electric field at the same point, which would be in the direction opposite to E1. Do you agree?
Yeah.
So cannot be there some point at which E1 equals to E2 in magnitude, because if for E1 is equals to E2 then the net electric field at this point would be 0, isn't it?
Yeah.
If E1 magnitude is equal to the magnitude of E2, then the net electric field would be 0 at this point. They would cancel each other, correct?
Yeah.
So now let us find the electric field due to each one of these charges. Let us say this is Q1 and let us say this is Q2, and the electric field due to Q1 at this point would be radially outward. So this is E1. Electric field due to charge Q2 at this point would be E2.
Uh, okay, yeah.
Okay,
Yeah.
E2 vector. Now let us find E1 vector and E2 vector, correct? So what would
Yeah.
be E1 vector, or let's say, because he is asking the intensity, so we can also find the magnitude. So E1 modulus would be KQ1
Q.
by R square. And what is
That's
R?
fine.
The distance of this point P from that charge, which is x square.
Yeah. Yeah.
For the second electric field, which is E2,
2 KQ2.
would be electric field at this point due to this charge Q2 would be KQ2 upon 2
On
minus x
2
whole
minus
square.
x whole square.
Now we need to equate them, because he says that find the point on the line where the electric field is 0. So we need to put this electric field in prior to 0, because this point is, this is variable, the x is variable. We have just assumed this as the
Yeah.
point, correct? So let
Yeah.
us say that at this point P, let us say this the electric field is 0, then what would happen? E1 would be equal to E2.
Yeah.
So let us do that and find what we get. So KQ1 by x square should be equal to KQ2
KQ2
upon 2
minus
minus
x
x
square.
whole square. K cancels out, and we can substitute the values. So when we substitute the values, this 10 to the power 19 and 10 to the power 19 would cancel each other, and what we would get is 5 upon x square is equals to 20 upon 2 minus x
2
whole square,
minus x
isn't it?
square. Yeah.
Because they would readily cancel, same power, no?
Yeah.
5 4 is 20. Now to solve this equation for x, 4x square is equals to 2 minus x whole square.
Yeah.
So 4x square is equals to 4, and just using a minus b whole square, so a square plus b square
X
minus
square.
4x, correct?
Yeah.
uh, let's take everything in here. So 3x square was 4x square minus x square.
Yeah.
This would become positive, this
Plus
would become
4x.
negative, correct? Now how you solve this? 4 3 is a 12, correct? So 12 factors,
Yeah.
4 3 3 1 2 2 3, right? 6 and 4 2, 6 minus 4 2 is 4, isn't it?
Yeah.
So
Yeah.
3x square plus 6x minus 2x minus 4 is equals to 0, and 6 to the 12 is also 4 3 is 12, so we are getting everything right.
Yeah.
3x can be taken out common, which leaves inside x
X plus
plus
2.
2, and here readily
X
write
plus
x plus 2 inside to get
then
minus 2 outside.
right. Yeah. So
So
you get
3x
X
minus
plus
2
2.
is equals to 0 either, or x
Yeah.
plus 2 is equals to 0. Now solve for this, you get x is equals to 2 by 3, I think, is it?
Yeah.
And for this you get x is equals to negative.
Negative.
This would not hold
True.
true for this context, because he's saying we want to find a point between A and B where electric field is 0. And if we take x is equals to -2, x is equal to -2 would be somewhere here if we take this as the origin, isn't it?
Yeah. Yeah.
So that is not considered, and
Yeah.
hence x should be equal to 2 by
2
3
by 3.
meters. Let me see if this is the correct answer for the question. Yes, this is 2 by 3. Okay,
Cool.
so this is how we do these questions. I think the time is over, otherwise there are so many good questions for on this topic. At least two of them I wanted to do today. Anyway, we'll do it in the next class.
Okay.
Okay, I will send you the homework. All
Okay.
right. Okay.
Is that it?
Yeah, that's it.
Okay, so